created my own little algorithms to do one thing or another, like disease states, a mortality algorithm. And
I think you will have a whole levels of robotics, that humanoid robots or non-humanoid robots, whatever the case is.
But the one that I really gravitated towards was Alteryx. Low code, no code, business intelligence stuff, data science, machine learning, things like that.
Audio, the text, and then there's big metaverse bug. Everybody knows the metaverse.
Another week of AI.
Thank you all for joining for another episode of AI on our 5th season. And since we started in our early seasons, we had a focus specifically on military veterans community, transitioning out of military, and how to identify what careers and how that career will be impacted by AI, and how to give them some early insights into the AI possibilities. So 5 years ago, things were far different than it is today. Right now, we're seeing a major shift in the workspace and workforce that is targeting artificial intelligence as the career path forward, because augmenting intelligence, the AI, not artificial intelligence, but augmenting intelligence is the way forward. And how do we use augmented intelligence in our workforce and enhance our capabilities is what's at stake right now. So we are expanding our focus. Our focus is going from not only just military veterans transitioning, but military veterans that are already in their career path. They have already been out for a while and they're looking to switch careers or even enhance their possibilities with the possible income earning using artificial intelligence, be it a startup, be it an entrepreneur, be it just somebody who's working freelance project. So I think it's worth really focusing on the full workforce because through the workforce lenses, we can help more military veterans to understand the total of workforce and how they can differentiate themselves and stand out even for better opportunities. So in the 5th year, I guess we have to add more to what we have already been doing. So one of the things that we're going to try today is to use the actual movers and shakers of the industry, such as Jensen Huang, who individually with the company called NVIDIA is shifting the way we are doing business today. That is why the company's $5 trillion in CapEx, evaluation, right? So these capabilities that NVIDIA brings to the table is really what's driving us forward, sort of like how mobile revolution happened because of Apple and Samsung. And you can look back in the cloud space and say Microsoft and AWS, the two big players that shifted everything into the cloud space and the cloud activities, right? Through heavy investment and through heavy innovations. So as we're walking through these conversations, one of the things that you will realize is that there's lots of gaps in knowledge. And that's something that I've actually been really focused on, is identifying what does the subject matter experts know and what do they need to know in order to make that bridge between AI and their subject matter expertise. If you're a person who's been invited to this podcast to see this podcast, watch this podcast, and make comments and ask questions of the podcast during this FAQ sort of an environment where frequently asked questions, you can ask those here and you can get your personalized and curated answer for those questions. So if you've been invited to, join in this discussion, is mostly because you have most likely a non-technical background. That means you are that person who's going to be impacted by these AI decisions that either you will help lead or AI decisions that you will help implement, right? Adoptions of artificial intelligence. So the business processes are changing, workforce is changing, workspace is changing. That means we have to change with it, right? Person on the seat needs to have some professional development, upskilling. But upskilling is a difficult conversation to have because we don't know what question to ask and what point to start at. And that's not going to change necessarily overnight, but slowly as it does, I can tell you, I've been in this space for 10 years. When I first started using AI, I didn't even call it AI. It's just what it was. It was machine learning. It was something simple as that. And in the AI space right now, because of so much hype and marketing, so much marketing dollars coming through, because of the ROI on those marketing dollars is far greater than ROI into helping you do your workflow with optimization. Really, what comes down to it is that we have to understand it for ourselves, because marketing is not enough. Marketing has their own initiatives. We have to take our own initiatives and really capture these momentum for ourselves. And so I don't want to take too much of your time here. I want to make sure I want to stick under 45 minutes. If I go more than 45 minutes, I'll try to cut it under an hour. But the point is, I want to go as fast as possible with as much information as possible, because this is not the first time you're going to hear about these. You're going to hear more about these. But if you hear it first, take notes on them, chat GPT it, Claude it, Google it, however you want to approach it. But do understand a little bit more of these things that you will hear here. And then if you don't understand it, take notes on it, so that way you are able to have a sort of context built around the content that you hear today. Okay, so I'm going to start off with the video that is Jensen Huang in All In Podcast. I don't have access to Jensen Huang. I don't have access to many of these people on this panel, but if I can, articulate what is being discussed here in a non-techie fashion, I will do that. But of course, this full video is about an hour long, so I'm going to take a few of these clips and show it to you here and follow up with some information that might be helpful in order for you to understand the context of what is being discussed here. Jensen Huang's videos are thousands and millions available on YouTube. You can watch them all day long. But with this video specifically, what I would like to say is technical descriptions and how does that fit into the narratives of how you need to understand it as a person who's either going to lead, make decisions, or be impacted by those decisions moving forward with artificial intelligence.
75,000 in tokens for each engineer, something like that. So are you spending in NVIDIA $1 billion, $2 billion on tokens for your engineering team right now?
We're trying to. Let me give you the thought experiment. Let's say you have a software engineer or AI researcher and you pay them $500,000 a year. We do that all the time. Okay, this is happening all of the time. That $500,000 engineer at the end of the year, I'm going to ask them how much did you spend in tokens? And that person said $5,000. I will go ape something else.
Yes.
Right. If that $500,000 engineer did not consume at least $250,000 worth of tokens, I am going to be deeply alarmed. Okay, and this is no different than one of our chip designers who says, guess what? I'm just going to use paper and pencil. I don't think I'm going to need any CAD tools.
Right. This is a real paradigm shift to start thinking about these all-star employees. It almost reminds me of what we learned in the NBA when LeBron James started spending $1 million a year just on his health of his body, and maintaining it.
That's right.
Here he is at age 41, still playing. It really is, hey, if these are incredible knowledge workers, why wouldn't we give them superhuman abilities?
That's exactly
where does that go? If we extrapolate out 2 or 3 years from now, what is the efficiency of that all-star at NVIDIA and what they're able to accomplish? What do they look like?
Well, first of all, things that wow, this is too hard. That thought is gone. This is going to take a long time. That thought is gone. We're going to need a lot of people. That thought is gone. This is no different than in the last industrial revolution. Somebody goes, boy, that building really looks heavy. Nobody says that.
Right.
Nobody, wow, that mountain looks too big. Nobody says that.
Right.
Everything that's too big, too heavy, takes too long, those ideas are all gone.
You're reduced to creativity.
That's right.
What can you come up with?
Exactly.
Right.
Which means now the question is, how do you work with these agents? Well, it's just a new way of doing computer programming. In the past, we code. In the future, we're gonna write ideas, architectures, specifications. We're gonna organize teams. We're gonna help them define how to evaluate the definition of good versus bad. What does it look like when something is a great outcome? How to iterate with you? How to brainstorm? That's really what you're looking for. And I think that every engineer is going to have 100 agents.
Back to the PR problem the industry has right now. You have executives like David Freeberg with Ohalo, who's looking at literally taking, through the use of technology, your technology and AI, the number of calories produced and making high quality calories. What is the factor you think you can bring the cost down, Freeberg, and what impact does this vision have for what you're doing?
zero-shot genomic modeling, and it works.
Yeah.
And you have that moment, and you're like, holy shit. Honestly, like, and that's after people are replacing entire enterprise software stacks in a night. I did something in 90 minutes. I was telling the guys about, replaced the whole software stack and like a whole bunch of workload. 90 minutes on Claude, ran this agentic system, built the whole thing, deployed it, and we
on a Sunday night.
On a Sunday night, 10 p.m. I was done at 11:30. I went to bed.
As the CEO, you replaced.
Yeah, and
software.
Everyone on my management team had to do a similar exercise over the weekend. What we saw on Monday, I was like, it's over. But the technical stuff, the science stuff, we did something in 30 minutes using auto research. And I'd love your view on auto research and what that tells us about how far we still have to go in terms of efficiency. But using auto research and a chunk of data, something was published internally that we said, oh my God. And that would normally be a PhD thesis that would take 7 years. That would be one of the most celebrated PhD theses we've ever seen in this field. And it would be in the journal Science. And it was done in 30 minutes on a desktop computer running on auto research with all the data we just ingested. We got it on Friday and we're like, hey, let's try it. Boot it up, go into GitHub, downloaded auto research and ran it. And you see everyone's face just go like, and then the potential of what this is unlocking for us is like the kind of thing that would take 7 years. And it happened in 30 minutes. And we're experiencing it in genomics. And we're like, this is unbelievable. So I think like the acceleration is widening the aperture for everyone in a way that like you didn't imagine a few years ago. But just going back to the auto research point, can you just comment on what you think about the fact that this thing got published with 600 lines of code in a weekend and the capacity that it has to run locally and achieve what it can achieve with all of these diverse data sets, and what that tells us about the early stages we are in terms of optimization on algorithms and hardware?
The fundamental reason why OpenClaw is so incredible, number one, is its confluence, its timing with the breakthroughs in large language model.
Yeah.
Its timing was perfect. It was impeccable.
Yeah.
Now, in a lot of ways.
So what you heard there is changes in token usage, right? Token usage means you have these large language models that are using tokens to do what large language model shows to you, right? So when you give it a question, there's token that is being used. And when it's sending it back to you, there's tokens that's being used. So when you calculate these tokens, amount of tokens sort of should remind you of amount of work hours that you have for a business. So if there's a business that employs certain amount of people and certain amount of people does certain amount of work in hours. So when you do that task management analysis, all these numbers combined, what you're looking at is amount of hours that we have spent on our task. Have we gotten the return on investment? So for token, it's sort of like return on token, right? If we use this much token, if we spent this much on the token, did we get all the return on investment into that token? Sort of like how we talk about with return on data. If we process this much data, if we do these things with the data, the amount of hours we spent on it, the amount of tokens that we put into those data, was there a return on investment for that, right? So if you look back in early stages of Jensen Huang's, not early stage, about 4 or 5 years ago, when Jensen Huang would give his GTC speeches, he would talk about things like business intelligence. So every step of the way in business intelligence, not only can you calculate what you've been previously able to calculate for your enterprise resource planning, your supply chain planning, management, operations, daily budgeting, monthly budgeting, daily task, all these things inside of business intelligence, you can get to a point of collecting microsecond worth of information and combine those microseconds of information to find a beautiful picture of where your business has been or as is and where is it to be, right? So these sort of decision-making capability really ignites because of artificial intelligence, large language model, and tokens. But tokens as the whole new layer for you as a decision maker or leader or person who's in the team to contribute in these capabilities, because what that does, it creates a stronger outlook for the future. And as you can tell, a lot of the commotions that are happening in the software space right now, it is just that, right? The fact that if anybody who uses Jensen Huang's product can code overnight, like that gentleman described to you, that, in 90 minutes, he was able to code things that previously he probably would have had to outsource to somebody else, right? Outsource it based on hours that he will allot that work to be done. And that person will do it. And then that person will come back and say, I need more hours. I probably didn't do enough bug fixing. I need something on top of what the hours have been allotted. So now you can imagine that goes from a certain amount of hours, like 80, 90, 100, 200,000 hours, whatever the numbers are. Now all of a sudden it's the opposite. It's the minimal amount of hours. It's the ideation that will take longer, the exploration that will take longer, debugging that will take longer. But to execute, it's 0 to day one very, very easily, right? So these are the sort of capabilities that tokens are bringing to the front. So when you hear somebody who's getting paid $500,000 a year using less than $5,000 in token, it's a very, very disturbing scenario, because you are being paid to use these tokens, and you have to burn through these tokens, not necessarily just burn through them and not provide an output, but that output is being tracked based on the token that is being burned. So the workspace, the workforce, the shift is tokenomics, right? The shift is tokenomics, and this tokenomics requires some hardware capabilities that we will talk a little bit more about. But before we do that, let's get into the next clip, and then we'll talk more about the workforce and the workspace.
Conversation has revolved around this concept of agents making people superhuman, and the business opportunity expanding and entrepreneurship expanding. You actually saw it pretty clearly. Yeah?
Have you changed your view?
Well,
I'm not Doomer.
I do have.
Love Doomer.
No, you can hold space for, I think, two ideas. One is there are going to be a
That's spiral J Cal.
No.
But that's just because he doesn't hang out with me enough.
But we've hung a little bit.
Be careful.
We don't talk about it.
He will show up at your breakfast table.
He'll follow you around.
I'm not asking for it.
He will follow you around.
I'm not asking for it.
You can come with me and Tucker. We ski in Japan every January.
Really?
Love it.
Oh,
You and Tucker will go road trip.
Wow.
No, there is going to be job displacement, and then the question becomes, do those people have the fortitude, the resolve to then go embrace these, technologies? We're going to see 100% of driving go away by humans. That's a beautiful thing in the lives saved, but we have to recognize that's 15 million people in the United States, 10 to 15 million, who are employed in that way, and so that is going to happen. Yes,
I think that jobs will change. For example, there are many chauffeurs today who drives the car. I believe that many of those chauffeurs will actually be in the car, sitting behind the steering wheel while the car is driving by itself. And the reason for that is because, remember what a chauffeur does. In the end, these chauffeurs, they're helping you. They're your assistants. They're helping you with your luggage. They're helping you. They're helping you with a lot of things. And so I wouldn't be surprised, actually, if the chauffeurs of the future become your mobility assistant, and they are helping you doing a whole bunch of other
check
stuff.
into the hotel,
and the car's driving by itself.
The
And
autopilot in planes created a lot more pilots and didn't take any of the pilots out of the cockpit. Even though the
That's a very good point that was made about autopilots in the aircraft, and airline industry has been using autopilot for a very long time. That does not mean that pilots are out of job. So one of the things that I really want to bring about in this conversation is a lot of the conversation about the software engineers. A lot of parents will say, my son is in school for software engineering, and a lot of other people will say, I learned coding for the last 5 years. What's next? You can take my word for it, or you can, jump in and figure out what are the actual demand signal looks like beyond the media headlines. Is that the demand signal is we need more software engineers now than we did before. And the fact is, we have only done coding and ideation for the fixing logics or fixing functions and fixing workflows using codes, almost 1% of what we have discovered so far. That's just what we have discovered so far. We have actually tackled a very small amount of things that we want to code against and turn that into an automation. So when you think about the rest of the work that hasn't been done yet, that is still going to require software engineers, a lot of people that are system engineers that has understanding of how coding works, how you can start writing a code, how you can deploy that code, and once you deploy it, how do you maintain that code? And if you have to maintain it, what does the life cycle of that code looks like? So you're a total engineer of everything that is code based, but that does not mean that code goes away. So one of the topics that goes really untold is that the systems are still going to use code in order to do what a system does. And in other words, I mean your laptop. In other words, I mean your routers, your switches, devices that you don't necessarily interact with. They're all code based. They're always going to use code in order to do what they do inside of a machine, inside of a semiconductor chips, inside of a device that could be that washer and dryer, right? These washers and dryers are not going to process your human English language or human Mandarin language or human German language, right? What it's going to do is process the zeros and ones, but at one point that zeros and ones becomes a gatekeeper, so we move on to the quantum computing space, which is down the road. But until then, we have zeros and ones, and those zeros and ones requires coding. So this human language that is translated into the computer language or machine language, now you are seeing not stack of layers of coding, but just a single layer maybe, right? So when you're talking about like, hey, what happens to the software engineers and coders? Software engineers and coders are going to level into a specific language that is really hard at this time in the century, but that's the only language that's going to be left, because once you have few languages that you can work with, that's how we have started. That's what we're going back to, because that's what made all sorts of chaos and confusion in the system, because there's so many codes and so many different ways of writing those codes in order to just translate it into a machine language. So software engineers are going to have more roles and more jobs in the future, which I believe in, and the demand signal says so, because that's what system requires. Just to give you an example of what I just said right now, is that if you thought Silicon Valley, the big software companies, had a lot of software engineers, it's because they did. They were holding on to many of the software engineers, but the rest of the world, rest of the industries outside of Silicon Valley, outside of software ecosystem, they did not have access to those software engineers. Now they do. Now the software engineers are able to come out and say, what you used to outsource to outside of your company, now I can bring that in and actually develop a lot of your logics and things that previously you had to rely on somebody, third party, or from outside of your organization or corporations, or away from your parking lot. Now we can do it in-house. Now we can do it in your corporate environment and have that continuously be developed, continuously launched. But now imagine you hire that one person, and that person is using lots of tokens to write those codes. And they're not writing one specific problem. They're writing for 30, 40 problems specifically throughout the week, because that's how much faster they're writing those codes. If they're writing those codes and you hire a team of, say, 5, where you had a team of 0 doing the software development for you, now you have a software development, literally a corner of your building that's dedicated to software development. That's how it is in many of the software organizations. And now you're going to see that inside of Bank of America. You're going to see that inside of industries that are not software developing business, right? So these hiring capabilities that are coming down the pipeline, yes, there is some downtime to it, but the catching up part of it is getting faster and faster, because people are realizing that, yes, AI can code, but AI cannot code because AI doesn't necessarily have the ideas, right? So software engineers are one part of the equation that I want to tackle, but the other part I want to tackle is the non-techies. The non-techies are going to code far more than what they ever thought they will, right? And the software engineers and developers are not going to be necessarily the first ones to initiate that code, first ones to deploy that code. What they will most likely come in for is the maintenance side of the code, the triggering side of codes. Maintenance and monitoring and triggering is something that you will see in the AI space, the machine learning space, more frequently than none. But think about it from the perspective of, once you, as a non-techie, have developed a code and launched it, now that you have launched it, everything works fine for day 2 and day 20. However, eventually stops kind of not working so great and having lots of issues and errors. And you can do that yourself, but that keeps you away from your subject matter expertise on what it is that you're really good at. Why don't you let the software development team handle that, so that way they can take your logic and workflow that helps you to do your job, right? I guess the right wording here is that you're not using AI, but you're working with the AI. If you're working with an AI, it's because you developed that code as a non-techie. So say, for example, you're a CPA accountant. The CPA accountant has so many logics that they would like to work with, yet it's just something that they cannot code against. But all of a sudden, now that you're coding against it, you deploy it, and you are seeing it works phenomenally, but you would like somebody to help you sustain and scale it, right? Better yet, give you interoperability, which we call KISS, K-I-S-S. Keep it iterable, scalable, and sustainable. So as a non-techie, as you're coding, you are working with an AI, and you are seeking the help of the software development to say, like, how do I sustain this? How do I scale this even further? How do I build that interoperability if I haven't already built it? So there's lots of things to be discussed, lots of things to be really made decisions on in day one, because we're in day 0 right now. Day 1 to day 30, day 30 to day 100. What do we need to make decisions on? We really have to get some preparations behind that. So the next clip we'll play, we will talk about just what I just said, right? But kind of want to hear from Jensen Huang the way he will explain the same.
Some jobs will be eliminated. However, we also know that many jobs will be created.
Yep.
The one thing that I will say to young people who are coming out of school, who are concerned, who are anxious about AI, be the expert of using AI.
Yes.
How much? Look, we all want our employees to be expert at using AI, and it's not trivial, And so knowing how to specify, not to over prescribe, leaving enough room for the AI to innovate and create while we guide it to the outcome we want. All of that requires artistry.
You had this great advice to when you were at Stanford, I think it was, which is, I wish to you pain and suffering. Do you remember that?
Yeah.
Fantastic. What's your advice to young people around what they should be studying? So if they're sort of about to leave high school, because now those are the kids that are at this like really native, they haven't made a decision about college, what to study, if at all go to college. How do you guide those kids? What would you tell them?
I still believe that deep science, deep math, language skills, as you know, language is the programming language of AI.
The ultimate programming language.
And so as it turns out, it could be that the English major could be the most successful.
Yeah.
And so I think I would just advise whatever education you get, just make sure that you're deeply expert in using AIs. One of the things that I wanted to say with respect to jobs, and I want everybody to hear it, that in fact, at the beginning of the deep learning revolution, one of the finest computer scientists in the world, I deeply respect, predicted that computer vision will completely eliminate radiologists, and that the one field he advises everybody to not go into is radiology. 10 years later, his prediction was at 100% right. Computer vision has been integrated into all of the radiology technologies and radiology platforms in the world 100%. The surprising outcome is the number of radiologists actually went up, and the demand for radiologists is skyrocketed. The reason for that is because everybody's job has a purpose and its task. The task that you do is studying the scans, but your purpose is to helping the doctors, helping the patient diagnose disease.
Right.
And so what's surprising is, because the scans are now being done so quickly, they could do more scans, improving healthcare.
Yes.
But doing more scans more quickly allows patients to be onboarded a lot more treated a lot more quickly.
Yeah.
And as it turns out, because hospitals enjoy making money too.
Yeah.
Right.
They're doing more scans.
Treating more patients.
Treating more customers and
Early
more
detection
patients.
becomes
Their revenues go up.
Perfect
And guess
example.
what?
Perfect
Need
example.
more. Yeah.
And in a country that grows faster, productivity increases, a wealthier country can put more teachers in the classroom, not less teachers in the classroom.
That's right.
You just give every one of those teachers a personalized curriculum for every student in the room. It makes them all bionic and leads to a lot more.
Every single student will be assisted by AI, but every single student will need great teachers.
Yeah.
I mean, so what you heard there is the involvement of more people joining the workforce in order to work with an AI, and people that are already in the space, that are in the mid-level manager positions, they're going to work with AI. So what that means is the tokenomics, like we talked about earlier, is going to have agents are going to use tokens, humans are going to use tokens, and somewhere in between, we're going to have a system and humans that are checking those tokens usage, right? Because we still have to make decisions about more token usage. Where does the tokens go? So if you have already started using tokens, that means you know exactly what I'm talking about. But if you haven't, one of the things that you can do, position yourself early to say that middle piece is where most trouble will come going forward, right? Because as things starts on day one, this is tiny, but this is the one that grows eventually, because this is what's going to dictate how much are the human will use the tokens and how much will the AI agents will use the token. And are these AI agents really creating these tokens with security in mind, privacy in mind, safety in mind? Because the humans are the subject matter experts of whatever the task that is being conducted. And they can do their own security, their own safety, but there's always going to be that middle piece that's going to have to keep an eye on these agents and say, yeah, these agents are not being manipulated by somebody outside of this organization. So you can imagine cybersecurity and threats of vulnerabilities that's already surfacing with OpenClaw. And you will hear a little bit more about OpenClaw on the next clip. But before we dive into that, I just want to bridge into what I said before we played this clip, and what has been said on this clip is that you need to really think of it as there is a media hype and there is an industrial needs actually, right? Because one of the things that we really don't think a lot about AI taking jobs is that AI is going to do a lot of our jobs. There's no doubt about it. But that also need to be dealt with in the fashion that there's a lot of people that are going to leave the workforce eventually, and we already have shortages of workforce. So there's lots of things that robot can do that are repeatable and redundant and sometimes dangerous. What we have to do is understand that what we do in the future, how we do things in the future, will have to differ between how we've done it for the last 100 years. Because in the last 100 years, we have outsourced many of our jobs to automation. We already have that. This is just a continuity of it. But one of the things that we haven't seen previously is amount of people leaving the workforce and amount of shortages of people that we will have in the workforce, because the population is declining, right? Population that is declining not for necessarily the next 10 years, but you can imagine 50 from now, right? So there's lots of ways to come at this, but for a person who's thinking about artificial intelligence today, we really have to think about how to mature ourselves with it, because we want to work with an AI, because this is not a use and stop using kind of a use case, right? This is going to be something that is going forward. We're going to keep using these large language models, because that large language model is something that is actually sustainable and scalable. Right? We're not so sure about everything intelligent, but the software 3.0, which is another way of saying large language model, or ChatGPT or Claude from Anthropic and OpenAI or Microsoft Copilot, these things are here to stay. These things are what's going to write the code. Because if you think about for the last 100 years, one of the things that actually held us back, and you can debate me on this one, but I can kind of stand my ground here, is to say, the coding has halted all the human progressions for the last 70 years, right? If we can code even better, that's what we needed, really. So this is a point of convergence where we are going to actually be able to use more coding, do more coding, and do this coding not by techies, by the non-techies, by the subject matter experts specifically. So if you're a CPA, if you're a person who's doing taxes, or if you're a person who's just running a plumbing business, right, you will be able to code more and you'll be able to do more. Just to give you an idea about where things are heading, is that you have to talk about agent-to-agent protocols, right? This is something that I discuss over and over in many of my video segments, is to give you that perspective into right now, people do business with people. But you can only, as a person, you can only do businesses with so many people because you have so many limited hours in the day, so much limited cognitive capabilities, and so much limited efforts and energy that you can be somewhere physically all at once, right? But now that there's a physical agent version of you and there's multiple agents that are working on your behalf, now you're going to have agent to agent businesses, right? And these agent to agent businesses are already taking shape because there's payment system that is made for agents, systems that can go and buy things on your behalf and preferably buy from another agent. So there's an accountability built into it, and less scam that could happen like we have people to people right now. So I'm going to jump into the next clip, but these are some of the terminologies I really want you to get familiar with, because if you have questions and comments, feel free to drop them here and I'll be able to get on them and give you a personalized way of answering those questions for you. Because most of the time, these questions are very vague and satellite level. What we want to do is really bring them down a notch and say, how do we personalize this information so that way you don't have to spend 10 years like I did trying to learn all this information. Maybe in 10 minutes, you can learn a lot more than what I did in 10 months. Just a challenge.
2.5 years ago, I introduced the operating system of the AI factory, and it's called Dynamo. Dynamo, as you know, is a piece of instrument, a machine that was created by Siemens to turn essentially water into electricity. And Dynamo powered the factory of the last industrial revolution. So I thought it was the perfect name for the operating system of the next industrial revolution, the factory of that. And so inside Dynamo, the fundamental technology is disaggregated inference. Jason, I know you're super technical.
Absolutely.
I know it.
I'll let you take this one. Go ahead and define it for the audience. I don't want to step on you.
Yeah, thank you. I knew you wanted to jump in there for a second, but it's disaggregated inference, which means the pipeline, the processing pipeline of inference is extremely complicated. In fact, it is the most complicated computing problem today. Incredible scale, lots of mathematics of different shapes and sizes. And we came up with the idea that you would disaggregate parts of the processing such that some of it can run on some GPUs, rest of it can run on different GPUs. And that led to us realizing that maybe even disaggregated computing could make sense, that we could have different heterogeneous nature of computing. That same sensibility led us to Mellanox.
Yep.
You know, today, NVIDIA's computing is spread across GPUs, CPUs, switches, scale up switches, scale out switches, networking processors. And now we're going to add Grok to that. And we're going to put the right workload on the right chips. You know, we just really evolved from a GPU company to an AI factory company.
I mean, I think that was probably the biggest takeaway that I had. You're seeing this fundamental disaggregation where we've gone from a GPU and now you have this complexion of all these different options that will eventually exist. The thing that you guys said on stage, or you said on stage, was I would like the high value inference people to take a listen to this, and 25% of your data center space, you said, should be allocated to this Grok LPU GPU
we should add
combo.
Grok to about 25% of the Vera Rubins in the data center.
So can you tell us about how the industry looks at this idea of now basically creating this next generation form of disaggregated prefill, decode, disag, and how people do you think will react to it?
Yeah, and take a step back. And at the time that we added this, we went from large language model processing to agentic processing. Now, when you're running an agent, you're accessing working memory, you're accessing long-term memory, you're using tools, you're really beating up on storage really hard. You have agents working with other agents. Some of the agents are very large models. Some of them are smaller models. Some of them are diffusion models. Some of them are auto-regressive models. And so there are all kinds of different types of models inside this data center. We created Vera Rubin to be able to run this extraordinarily diverse workload. My sense is, and so we used to be a one rack company. We now added 4 more racks.
Right.
So NVIDIA's TAM, if you will, increased from whatever it was to probably something, call it, 33%, 50% higher. Now, part of that 33% or 50%, a lot of it's going to be storage processors. It's called Bluefield. Some of it will be, a lot of it, I'm hoping, will be Grok processors. and some of it will be CPUs, and they're all going, and a lot of it's going to be networking processors, and so all of this is going to be running basically the computer of the AI revolution called agents,
right?
The operating system of modern industry.
What about embedded applications? So, my daughter's teddy bear at home wants to talk to her. What goes in there? Is it a custom ASIC, or does there end up becoming much more kind of a broader set of TAM with developing tools that are maybe different for different use cases at the edge and an embedded application?
We think that there's 3 computers in the problem at the largest scale when you take a step back. There's one computer that's really about training the AI model, creating the AI. Another computer for evaluating it. Depending on the type of problem you're having, like for example, you look around, there's all kinds of robots and cars and things like that. You have to evaluate these robots inside a virtual gym that represents the physical world. So it has to be software that obeys the laws of physics. And that's a second computer. We call that Omniverse. The third computer is the computer at the edge, the robotics computer. Right. That robotics computer, one of them could be self-driving car, another one's a robot, another one could be a teddy bear, little tiny one for a teddy bear. One of the most important ones is one that we're working on that basically turns the telecommunications base stations into part of the AI infrastructure. So now it's a $2 trillion industry. All of that in time will be transformed into an extension of the AI infrastructure. And so radios will become edge devices, factories, warehouses, you name it. And so there are these three basic computers. All of them, are going to be necessary.
Jensen, last year, I think you were ahead of the rest of the world in saying inference isn't going to 1,000x.
Just last year?
Yes.
Brad, you're hurting my feelings.
Is it going to 1 millionx? Is going to 1 billionx?
Yeah.
Right? And I think people at the time thought it was pretty hyperbolic because the world was still focused on pre-scaling, on training.
So the last part of the recording, as you've seen, they're talking about inferences. This is part of the conversation that things are really moving fast because one of the ways I've explained it to anybody and everybody that says, like, where is AI today? Well, AI is really stored in places all around the country in these giant data centers and these giant systems that cost billions of dollars. But the problem with it is that from your device to that data center, the ability to go back and forth and get what you need from those AIs is going to become a real bottleneck. And this bottleneck, you can kind of reverse engineer it from memory side of things. So let's say, for example, there are a lot of stored information in those data centers, but the memory in your device and memory on those devices are really not up to the scale, the level of memory it needs. So memory has been a problem. Memory will be a problem. Memory is coming up to be a problem. And on top of that, some of these natural resources like helium is part of the conversation where if you have questions about helium, I can answer those as well. I can answer a lot of your hardware questions along with software and data and cybersecurity questions. But this is some of the things that you really have to think through as you make decisions about the inferences. Because now not only are you using tokens, you are using those tokens through inferences. And so you really have to get smart with optimizing those token usage. So one of the things about tokens that you will hear more about is the context window. One of the very easy understanding of that is like, hey, you have this much tokens that you can have inside of this context window. But one of the things that really goes missing is there is a invisible tokens that are behind the scenes that are running that we're not necessarily aware of, right? Even if we are aware of it, we have to be mindful of it, right? Mindful of the fact that in this context window, where does system starts hallucinating, right? Or not necessarily a system, but that context window itself, where does it start hallucinating? Because once you have crossed that threshold of the context window, everything above that threshold is forgotten. But that's where all the main conversations are happening. So if you don't have that context window and understanding of usage of the token inside of that context window, you might have tokens that looks like optimized, but at the same time, it's not producing the return on investment. It's not giving you the work that you're supposed to get. So, there could be a double the work, there could be triple the work, but there's other things like, you don't want to load the context heavily. So that way, if you load this much, system processes maybe this much, but forgets to copy this part, right? Because it took so much effort to get to that middle part. So as you're hearing Jensen Huang speak on these topics, some of the things that you're hearing is GPUs, right? The computations. And I think this is something that I want to leave you with is the physical AI, the AI hardwares that you actually own. Because like I said, that context window, if it's being processed out in the cloud so far away from you, there's a cost associated with that, right? Because the data has gravity, data is physical. So when it travels in between places, it costs somebody money, and you have to pay that whatever that cost is. And there's another piece of it is that if you have the hardware right under your feet, where you can just stomp your feet and touch that hardware, that's the hardware that you own, and that's where the tokens are being generated from and being processed. All of a sudden you have a different sort of approach to the usage of token and running your business using those tokens. So let's say, for example, you'll hear about Grok, you'll hear about LPUs and GPUs, CPUs. I talked about memory. These all things are really hard to come by. And one of the things that I've been telling most people is to say, like, look, if you want to go ahead and make this purchase right now, you should go ahead and make this purchase right now, because as the demand signal goes up, supply and demand causes the prices to shoot up. We are seeing that already happening with some of the manufacturers, where they're saying, I am not going to focus on consumer products anymore. I'm just going to give NVIDIA everything needs. So I literally will stop supplying to people that used to buy my memory, but now I'm just going to focus on NVIDIA and give everything that NVIDIA needs as far as memory goes. So there's memories, GPUs and CPUs and LPUs and all sorts of NPUs that are coming into the market. There's a lot of the supply chain doubts and supply chain questions that are coming up because of, one thing I mentioned is the manufacturing. The other part is helium. How do they manufacture even manufacture now that there is this helium purification problem? Like, there's heliums out in the world, but it has to be so pure, 99% pure, that if you don't use that helium, you're not going to use any other helium for that manufacturing of memories and GPU chips in a semiconductor chips industry. So I'm going to leave you here with that. But the piece that I wanted to really bring all this into is the physical AI. The reason I ended up this conversation with the hardware is physical AI. So one thing that you should do after you watch this video is go to ChatGPT, Google it, go to Gemini, go to Claude, and type in physical AI and type in your business and say, how does physical AI in my business come side to side, work on something that either helps me capture a bigger market segment, helps me with a better revenue next year, or how does it even improve my experience for my employees, for my customers, for myself, process optimization, things of that nature. How does physical AI help me with that? But one of the things that I want you to think about is a physical AI. Think of IoT, right? Internet of Things. So when you type in physical AI, maybe look around at some of the IoTs that you're using and say, how do we turn that into a physical AI? And what are some of the steps and cost benefit analysis of such innovations or investment? So I hope that 45 minutes you've spent here has been worth it. We would like to have you come back and do more of these live stream videos that we do. And ask us questions live, so that way we can answer it after the show is over. So that way we get to learn from your problem sets. So what are you dealing with? What are some of the concerns that you have? Because that's how we actually stay on top of the game, because AI space is moving so fast. If we're not really addressing the latest problem, we are already a few months behind, few years behind in some cases. So until next time, AI is out. We'll see you soon. Ciao.